This is Laura Duncan from CSMS. Today we're going to be discussing the distributive property and combining like terms. We'll start with some definitions. A term is a variable or a number that is added or subtracted. Like terms are two or more terms that have the same variable. You'll find later they must have the same power and the same variable to be like terms. Simplest form is when all like terms are combined in an expression. Let's look at adding and subtracting terms. On number 1, we're trying to find out if these terms are alike. To be alike, they have to have the same variable. And when they have the same variable, we just add the coefficients or the numbers in front like normal. So since they have y as their variable, we have 3 plus 2. That's 5y. 5y is as simple as it can get. That is in simplest form. Look at number 2. We have the variable x and 2x. In front of this x, the coefficient is an understood 1. Since these are like terms because both of them have x's, we add the coefficients. 1 plus 2 is 3. We have 3 x's. We've added the like terms, and that is our simplest form. Let's go on to number 3. In number 3, I don't see any like terms. X is a different variable from y. They are not alike. Since they are not alike, we cannot combine them. So number 3 is already in simplest form. We cannot combine them. If we combine them, it'd be like mixing lions with bunnies. It would be a hot mess. So save the bunnies and combine only like terms. On number 4, we find 3 different variables. We can only combine the variables that are alike. So let's combine the terms with w's. We have 3w and 2w. We add the coefficients. 3 plus 2 is 5, and the w remains the same. Notice that we still have this 5m. W and m are not like terms. Therefore, this is our simplified answer. It is in simplest form, and we are done with the problem. Let's go on to number 5. On number 5, we're looking for like terms that we can combine. I see a D here and a D here. In front of that D, there is an understood 1. It's like it's invisible. It's just understood to be there. So when we're combining these two terms, don't forget that that's a 1. We add the coefficients. 6 plus 1 is 7. So 7D plus 15. The 15 is not a like term. It does not have the same variable. So this is in simplest form. We're done. Looking at number 6, we're looking for like terms. They have to have the same variable. So when we are combining these, I want you to be sure that you see that this is 16k. However, this is what most 8th graders miss. This is negative 5k or minus 5k. So if we're combining these, we'd have 16k minus 5k. That would give us 11k. Don't leave off that plus 9. The 9 and 11k are not like terms. So therefore, it is in simplest form. When we're multiplying terms, we don't care if the terms are alike or not. we can multiply any terms. So when we have this 3 and 4v, we simply multiply the coefficients 3 and 4. That would give us 12, and then have a v. So the final answer would be 12 times v, or 12v. On number 2, this means multiply right here. So we have 8b times 7. We multiply the coefficients. 8 times 7 is 56. And so we have 56b. That is our final answer. Number 3 sometimes confuses 8th graders because they're thinking about like terms, but in multiplication we don't care about the like terms. So simply multiply the coefficients. 4 times 5, that would be 20. But don't forget the variables. We're going to put the variables multiplied in alphabetical order. So our final answer would be 20xy. We can't simplify that anymore. Looking at number 4, I can see that we have a y here and a y here. However, we have to use the order of operations. So since multiplication comes before subtraction, we'll do 6y times 4 first. So that would be 24y. And then we'll subtract 5y. Now, at this point, you should be asking yourself, are these like terms? Because when we're talking about addition or subtraction, we're looking for like terms. They are like terms, so we can simplify it. We'll subtract the coefficients. 24 minus 5 is 19, so we have 19y. That's our final answer. Let's look at number 5. Again, we're going to use the order of operations even though you see a D here and a D here. It's something to keep in mind. First order of operations, multiplication. So we'll multiply the coefficients of 4 and 3. 4 times 3 is 12, so we have 12d. We're not going to forget to bring down our 15d. This is how you show your work, so please be sure to bring it down. We're asking ourselves at this point, are they like terms? Since they're both d's, they are like terms, and we'll just add the coefficients. 12 plus 15 is 27, so there are 27 d's. Box your answer. Let's look at number 6. On number 6, I see 2 like terms, but I'm not ready to combine them because I have to use my order of operations. This implies multiplication and this is addition. Since multiplication comes first, I'm going to do that first. I'll write down my 3k so I don't forget it, and then I'll add 9 times 5k. 9 times 5k, we multiply the coefficients. That would be 45. K. Now we ask ourselves if those are like terms because we're adding. Yes, they are like terms. So we add the coefficients of 45 and 3 to get 48k, and that is our simplified answer. So let's do a summary for multiplying and adding and subtracting. They are quite different. For multiplying, yes, we can multiply different terms. For adding and subtraction, we must combine like terms only. Let's turn to the next page, where we will learn about hippity-hoppity distributive property. You may have wondered, why do we learn about the distributive property? Well, it's because if we have terms like x plus 4, we cannot combine them because they're not like terms. Therefore, we must use the distributive property. So that means we will multiply the outside term, such as the 5 here, by every inside term. Let's practice that now. The 5 is the outside term. It is being multiplied. We'll distribute the 5 by multiplying it by every term. So 5 times x is 5x. Then 5 times positive 4 is 20. We look and see if we have any like terms. We do not. These are not like terms. So that is as simple as it gets. That's our simplified answer. Let's go on to number 2. On number 2, we cannot use order of operations to add 3x plus 5. So we must distribute the 4 that's being multiplied. 4 times 3x is 12x. The next term is 5. 4 times 5 is 20. We look for like terms. There are no like terms, so we box our answer. Look at number 3. On number 3, it's still being multiplied. However, the 8 is on the opposite side. But we still distribute it because it's being multiplied to each term. 8 times 3 is 24. And then 8 times y is 8y. Don't forget this plus sign. 24 plus 8y are being added. However, because they are not like terms, we cannot combine them anymore. Try the next 3 on your own. Please check answers 4 through 6. And let's define simplify. Simplify means to do everything mathematically possible. In mathematics, it's not possible to combine terms that are not alike. So please do not try to combine them if they're not alike. Simplifying means that you will try to make it the most simple by doing everything mathematically possible. Let's simplify each expression. Start with number 1. On number 1, I do see 2 terms that are alike. However, I must use my order of operations. I must multiply before I can subtract. So I'll do 3q times 4 first. That would be 12q. Then copy down the minus 2q. You're going to be asking yourself, are these terms alike? Yes, they are. They have the same variable, or the q's. So we subtract the coefficients. 12 minus 2. 12 minus 2 is 10. 10 q's. And that is our simplest answer. That is simplified. Go on to number 2. We can see that it's all addition here. So what we're going to be looking for is like terms. Do you see any 2 terms that are alike? Here's 14g and 3g. As you are combining these, I suggest you box this sign in front of the number, because this is 14g plus 3g. That would give us 17g. Don't forget your 2r. Since those are not like terms, we cannot combine them, but it is simplified. On number 3, we have addition and subtraction, but not all of them are like terms. We have 17h here, and then this is where students get confused. Is it plus 3h or minus 3h? Well, if you box the sign in front of the h, then you'll be able to tell. This is adding, so we will have 20h. 17 plus 3 is 20. Don't forget about that 14, but notice it's not plus 14, It's minus 14. So that is our final answer. Look at number 4. There's something a little different about number 4. If we were to use order of operations, we would look here and see that inside the parentheses, we cannot combine the 6 and the x. That means we have to use our special hippity-hoppity distributive property in order to do the multiplication before the addition here. So bring down this 6x, we're going to leave it to the side, and we notice this plus sign. We're going to distribute 3 times x. That's an understood 1. 3 times 1 is 3. We have 3 x's. And then 3 times 6, that would be 18. Now we're going to look for like terms. We have 6x here plus 3x. That would be 9x plus 18. And that is as simple as we get because we cannot combine 9x and 18. Try number 5 and 6 on your own. The lesson is yours. Please go practice assignment 1-5.